Hello everyone, my name is Linda Lee and I'm a graduate student majoring in electrical and computer engineering in University of Florida. And here is the final presentation about the course pattern recognition and intelligence, which was tutored by Dapeng Oliver Wu. My work is about the image segment, image feature extraction, face detection, and face recognition on Android platform. And you can see the basic structures of my work. And compared with those complex theories and explanations, I more prefer to do the demo part first. I can show you my app, which run in the Android virtual machine. And here is my app. The first interface is asking you to select an image from the database. And actually, I storage all of the image data on the cloud. I use the parse SDK, which was published by the Facebook. And here is the interface of the parse. You can see that there are different images and different users. Different users have the different authorized to access the different images. And here is the images for the user AI. Yeah. There are different kinds of images, and we can get one image to do the test. I think I prefer try the famous image in the image processing history. And let's choose this image. And here are the 4 functions, which are the separator, filter, feature extraction, and face detection. Face recognition is done in the Eclipse. I didn't integrate my result into Android platform. I will do later. So here are the basic 4 functions in the Android platform, and I must concede the separator and filter is a previous job finished in the image processing and computer vision course. But I combine the works in the image processing course with the pattern recognition course because of the filter and separator, which help segment the image and make the smoothing image, remove the light and the noise influence. We can do the feature extraction, face detection, and face recognition here. So here is the face extraction, feature extraction. Sorry. Yeah, here are the 4 types of the data. But besides these 4 types, there are also the data about the color coherence vector and color correlogram, but I didn't list here because the data is too much to show it on the phone screen. So I will only show you some figures, some figures which relate with image feature. Here is a gray histogram. Here is the RGB histogram. Here is the quantize of that picture. Here is the data. This data is about the color moment. It is the simple but efficient method to represent the image color features. And due to the color information is always distributed in the low-level moment, so it is enough for us to represent the color distribution by the mean moment, variance moment, and skewness moment. And here is the 3-level moment. I can show you the data. Here is the data. And then we can do the face detection. Yeah. If we click detect, we can see nothing from this image. Why? Because I must admit that my algorithm is not enough. So if it only can detect the image which have the enough eye features, and this image does not have the enough features. So we must choose some easy image, some more easy image to do the face detection. Maybe this, a beautiful girl. Yeah, let's try the face detect function. it works. And then maybe we can change another picture to do the face detection. In most time it is useful. You can see. And here face detection, detect, down. Yeah, in most time this function is worked. And here I can also show you the separator. It is the watershed algorithm which separates the image by the watershed algorithm. And here is a filter, Gaussian filter, which helps smoothing the image. And here is the jobs already finished on the Android app. And at this stage, let me explain the series of this project. First is the image feature extraction. I already explained the color moment, and here is the equations I used to calculate the color moment. Color moment is a simple but efficient method to represent the image color features. Another features I extracted is color coherence vector. Why? Because color moment cannot reflect the space information, color space information, but coherence vector can. It is one of quite complex histogram improvement algorithm, and here is the thresholding. I set it from a paper, and here is the result. In color coherence actor, it will divide every color cluster into two parts, which are aggregated and non-aggregated. In the process of image similarity comparison, compare their similarity separately, then combine the results to get the value. Here is the color coherence vector, and here is the basic process. Actually, I use this process to finish my program. Read data, quantification the image. You already see the quantification in the Android app. I already show you the result of quantification, and mark every pixel, right first traversal, and compare the value with thresholding. Here is the thresholding already set it, and then marked as a concurrence vector or marked as an concurrence vector, and do the loop, and finally statistic the data. Moreover, I use another expression of the color distribution, not only describe the proportion of one color in the whole image, also reflect the space relationship of one color. The characteristic of color parallelogram not only describe the proportion of one color pixels in whole image, but also reflect the space relationship of the different color. It's like an index of the colors. You can see the value here. Actually, the value represents the possibility of the distance of the two color pixels less than k. For example, here is one kind of color. Here is a value. Here is another kind of value. This is the possibility for these two can pixels. The distance is less than k. So here, the color parallelogram provides us with a comprehensive view of the color distribution color distribution and the features. So I actually divide it into 32 space, but here is only a part of the result. Here is the process I used to get the color parallelogram. It's read the image for each pixel in image, calculate the autocorrelation possibility and accumulation within distance of 1 to 10. so the K is 10, and the accumulation value divide the total pixels of one color, then calculate the result. Here are the three features, and three features which can quantification. And here are some other features, some other color histograms I already show you. This is RGB. Here is the HSV, and here is a gray histogram. And the next step, the next stage I finished is the face detection. There are many different features we can capture to detect the face, such as color, the gradient, or some other features. But in this app, the aim is to process a static bitmap and capture the eye features. So you can see that I marked the eye from the when I detect the face. First, I must catch the eye features. Then, I use the searching program to find the face scope of the image. And next is the milestone of the whole project, because we already have the quantification data, including color moment, color coherence vector, and color correlogram. And if we have all these data, can we build a neural network to achieve the face detection, such as, for example, in this database, these scores are the same. This is the same person, but in different pictures. Sorry. Yeah, here the same girl in the different pictures. Can we extract her face out and extract the features of this face, the color features? Though the features maybe have some differences, but there must have some common features. So if we use this data to training the network, can we use this network to recognize the new image of the same person, but totally different image? The person is same, but the image is different. Can we do this? So I write the simple typical BPN neural network, which inside interactive training, and actually the result is not very good. You can see that this figure, the data, the accuracy is always shaking, because each time enroll a new picture, the network cannot predict these new features, so it needs some time, some shaking to get the stable stage. So I use some algorithms, such as the test matrix, and you can see that here is two different types of functions to catch the weight, and I will only compare these two different functions and get the optimal result. And here I can show you the demo. So actually there is two different type functions, and here is the neural network, and here is my main function. And I can run this, so you can see that the hit rate will shaken, but it will stable in this stage nearly the 90%. And here is the weight, finally weight output, and we can see that, yeah, actually here is the data process finished, and here is the weight, and we can get a pretty accurate hit rate. And here is the data already read in. Here are the color moment, color correlogram, and color coherence vector. Yeah, so but actually this I must concede that the simple neural network is not enough to handle the face recognition such a complex subject. In order to do a more accurate job, maybe we need to enroll some knowledge around the deep learning and machine learning. But actually, I'm only a graduate student, and yeah, I really spend a lot of time in this project. I use I I do the jobs in Android platform, in Java, in Eclipse, and actually I have no time to do the machine learning. Maybe I will improve my job later because I already publish all these jobs into my GitHub. So I will improve later, but actually this is all the current jobs I have already finished. And yeah, that's all. Thank you. Hope this this simple but efficient app may impress you, and maybe I already show you what I already do. Yeah. Actually, I tried to finish. I tried to. I already remember the words Professor Dapeng Wu taught in the course. He told us that you should finish some really interesting things. So I do. I finished an app which can use and even put in the play market. So that's all. Thank you.